JPA basics. So here we're going to touch upon very simple concept of wall mapper, and then we are going to talk about what is and why we want to use JPA as the choice of wall mapper for Java application that needs persistence. We'll talk about top-level persistence requirements, and that is the set of design goals of JPA. And we'll talk about JPA wall mapping features. And then we'll talk about the concept of an entity. And then the rest of the session will cover very important concepts, which includes entity manager, persistence context, and persistence unit. So let's get started with what is and why use OR mapper, ORM in short. So why ORM? So major part of any enterprise application includes persistence feature, meaning it has to access and manipulate data that are located in relational database. Now, relational database is designed with tables, and the tables are designed for fast query operation, while in Java application, you work with classes and objects. And that is intrinsic mismatch between object model and the table model of relational database. That is what is called object and relational impedance mismatch. And wall mapper handles this mismatch for you. If you're not using wall mapper, then you probably have to deal with JDBC API, in which you are going to use JDBC API to access the database. And once you get the data, you have to assign those values of those data into your object. So you are responsible for the matching objects to the table data and vice versa. And that could be very, very hairy the task you have to do. By using wall mapper, all this impedance mismatch between objects and relational database tables are handled for you. So it makes your life a lot easier. Wall mapper has been around more than, I would say, 25 years, and they are very much optimized. So there is no reason not to use wall mapper these days, unless you have very optimized SQL, query string that you do still want to use it. Okay, so moving forward. Why JPA? So JPA is a standard ORM framework for the Java platform. It enables transparent POJO persistence, meaning you write code using POJO, meaning Java code, and when you need to persist the state of those objects, you basically let wall mapper to handle it. So the most popular wall mapper in the past used to be Hibernate, and Hibernate is still being used widely in industry. So JPA lets you build persistence object using common or object-oriented programming concepts such as inheritance and polymorphism. Now, as you're going to see moving forward, JPA is combination of API as well as framework, I would say. And so JPA, by writing your code using JPA API, you have a portability of the application. Now, as I said, JPA is also a framework in which you can plug in different persistence provider or persistent engine. Those persistent engines include like Hibernate and Eclipse Link and OpenJPA and things like that. So JPA actually provides good things on both fronts. It provides the standard Java API so that you can achieve portability of the application. It also lets you pick and choose the best persistence engine, such as Hibernate, to work as an engine underneath. So the trend these days is that people want to use JPA as a programming API, and they pick and choose, for example, Hibernate as a persistent provider. So you can take advantage of proven persistence engine in the market while you are writing your code using standard Java API defined in JPA. Okay, so just to give you a point in terms of JPA is API as well as is a framework. Okay, so let's talk about persistence requirements in typical Java application. So these are design goals of JPA. When JPA 1.0 was designed as part of the Java EE5, these are the goals. These were the goals the JPA specification lead had in mind. First of all, simplification of programming. So it will take advantage of some of the design principles, such as default over configuration. Sometimes it's called the convention over configuration. So in most cases, defaults are assumed. It eliminates the need for XML-based deployment descriptor, and that is a good thing. Another goal is to provide a lightweight persistence model, both from programming API model, programming model perspective, as well as runtime perspective that includes deployment. And runtime includes performance issues. And enable testability outside of the containers. By making entities as a plain poser classes, you should be able to test your business logic or your entity class in a very easy to test driven environment. And so basically, typically what you do is write your code and debug those codes during the daytime, and you want to test all your business logic, including your entities, as part of your nightly build process or continuous integration build process, for example, like a Jenkins or Hudson. Continuation of persistence requirements. Support rich domain modeling. So you want to be able to actually support inheritance and polymorphism among entities. Those domain models should be able to be mapped to tables in many different ways. Provide standardized and efficient ORM. So it's optimized for relational database. And it does provide a standardized set of annotations. And if you want, you can use XML configuration file as well. And by using this annotation, you can fine-tune the behavior of your mapper. And basically, the rest of the code can be learn those set of annotations and how to use and when to use those annotations. Providing extensive querying capabilities is important. So you want enable client application to perform query operation, leveraging a wide spectrum of querying capabilities. So it's pretty comparable to what Hibernate query capabilities. Support for pluggable and third-party persistent providers or provide persistent engines. So this is what I just talked about. You want to let people or the system administrator or a particular environment to be able to select best performing or whatever their choice of persistent provider. And in fact, persistent provider could be set in persistent unit. We're going to talk about the concept of persistent unit. It's basically represented by XML file called the persistence XML file, and you can specify your choice of persistence provider. Okay, moving forward. And common Java persistence API between Java SE and Java EE environment. So, persistent API should be able to be used in both Java SE application as well as enterprise application. So they want to let people to use the same persistent API. And that's what we are going to see later on. Mostly in our lab, we are going to build a Java SE application in which you are going to call JPA persistent API. And in some cases, we are going to build a web application or EJB application in which we are going to use JPA as well. So we're going to actually apply JPA in all these three environments, Java SE and web application and EJB application during this code camp. Okay, OR mapping. So OR mapping annotations, basically it provides, JPA provides a comprehensive set of annotations for mapping relationships, relationship between object to object, like a one-to-many, one-to-one, and many-to-many relationship should be able to be mapped to tables, and concept of joins, and how you customize tables and columns, and much more. Okay? So we can actually again spend the rest of the code camp learning all this different set of annotations that are provided by JPA. A very simple example. So let's say we have a customer class, and the customer has the setup order. So there is a one-to-many relationship between customer object to order object. So customer has many order object, and between customer and product there could be many-to-many relationship. So it's called the M to N. So a customer could have many products, and products could have many customers. And customer class have, in this case, name, C rating, photo, and you can see it has the collection, set of orders, and set of products. Okay? So what we want to do is we want to map this entity state to data store, meaning we'd like to use the annotations to map this customer class to customers table, and order entity to orders table, and same thing for product, and product should be mapped to products table. And also we have to specify the relationship between customer to order and customer and product. So all these things, all these relationships as well as entities need to be specified in the form of entities and their relationships. And that's something we're going to actually cover in a few minutes. Okay, so the most important annotation is entity annotation, entity annotation. So suppose we have a customer class. In order to make it as an entity class, you are going to annotate it with @entity. And inside customer class, we have ID field, and in this case, you see @ID annotation. That @ID annotation is used to specify this ID field is used as a primary key field in customer table. And then we have a set of fields, and each of these fields will be mapped into columns of the table. And if you want to specify a different column name, then you can use @column annotation. Okay, moving forward. So what is an entity? So you can think of entity as a plain old Java object. It's a POJO, and just like any other Java object, you could create entity object by using new keyword. And it supports object-oriented programming models such as inheritance, polymorphism, and things like that. Now, entity could be either in persistent state or non-persistent state. Persistent state sometimes is called the managed state, and non-persistent state is sometimes called non-managed state. We're going to actually talk about this concept of persistent state and non-persistent state in very much detail in the rest of this particular presentation. But for now, you can think of persistent state is an entity object that is maintained by what is called the persistent context, or JPA, the persistent provider. Okay? Again, we're going to talk about this one in detail moving forward. One example of non-persistent state is transient state. When an object is created, entity object is created brand new, it is in transient state, meaning it's not persistent state, meaning it is non-persistent state. And in order to make it a persistent state, you have to call persistent method of the entity manager. Okay? All right, so we're going to actually move on, and we'll again spend quite a bit of time learning the concept of persistent and non-persistent state. Entity has a persistent identity when it is in managed state or persistent state, because mostly it has corresponding row in the table. It can extend other entity or non-entity classes, because it's a POJO class. And it is serializable, and it's usable as a detached object in other tiers. And because entity object could be serializable, you don't need what is called the data transfer object anymore. Just to give you a sense of what the DTO is all about. Before entity was introduced, there was EJB 2.1, 2.x version. And in that case, entity was not POJO, meaning it was not serializable. So if you read data from the database table, and if you want to send that data into maybe web tier for the change by the user, you have to create another object in the middle, and that object will be initialized with a value from the EJB 2.1 entity object, and then that object will be serialized and sent to the web tier. So you have to have some kind of intermediary object that could be serializable, and that is called data transfer object. Now, because entity now in EJB 3.x is POSIX, meaning it's serializable, you don't need to have data transfer intermediary object anymore. So that is basically what we're talking about as a last bullet. Okay, so entity class is the class that is annotated with @entity. Okay, as I said, you can extend another entity class, and there is a small set of programming requirements. It must have a primary key field because it has to match to a row. An object of entity class has to match to a row in a table, so it should have a primary key field. It should have a public no-arg constructor, so they could be serializable without passing any constructor arguments. Instance variables must not be public, and it must not be final or have final method. So a very small set of requirements to make it as entity class. Okay, default mapping. So as I said before, your class will have a mapping to the table, and object of those classes will be mapped to a row in that table. Okay? Now, when we map entity class to a table, the name of the entity will be the name of the table, okay, as a default. So this is, again, conventional for configuration example. And if you want to specify different table name, then you can use @table annotation. Okay, again, we're going to actually do some lab on this one later on. Attribute name, field name or attribute name will be the column name as a default. However, if you want to have a different column name, you can use @column annotation. Data type mapping, the different databases will have a little bit of differences in this, but in general, string will be mapped into varchar 255, length of 255 in the table. Long and long will be mapped to big int, and double will be mapped into double, and boolean will be mapped to small int. So these are common data type mapping. So this is an example of entity class called the customer. Customer is entity class because it's annotated with @entity annotation. And it has a field called the ID, and that is annotated with the @ID annotation, meaning this field, the value of this field will be used as a primary key field. And then we have a name field, and then we have address field, and we have status field and order count field and things like that. Okay? We're going to talk about the embedded annotation and the transient annotation later on in detail. So I'm going to just move on. Okay, so entity identity is actually, again, specified with @ID and @generated value annotation. So every entity has a persistence identity, meaning it will be mapped to a key in the database table. Now you can use these two annotations, @ID, so you are going to assign a particular field to be the ID field. Generated value annotation is used along with the ID annotation. This is optional, by the way. So this is instruction on how to generate ID value. So if you use auto, then you're basically letting the JPA, the persistent provider, to choose depending on the database for you. Identity is using database identity column. Sequence is using database sequence, and table is to use sequence table for key generation. In most cases, you don't have to actually specify the scheme of generating ID. In fact, you don't actually use generated value annotation in most cases. So in most cases, you're gonna see just @ID annotation. Okay, so we are going to do our first hands-on lab, exercise 1, JPA basic annotation. So we're going to actually exercise all the concepts that we have covered up to this point. Okay, so since this is our first lab, I'm going to explain how to do the lab, especially if you are a first timer to JPassion.com. So basically, once you get to Java EE5 Programming website, you are going to see this JPA and you are going to download this lab. Okay, these labs are available only to paying members. So if you are not a paying member, then you are going to just watch the demo. Okay, so you save this file. I have already downloaded, so I am going to I have downloaded in the lab directory here. So I have downloaded all this JPA hands-on lab. So the first one we are going to work on is 4320 JPA Basics Lab, and that's basically what we have downloaded here. Okay. All right. So I'm gonna unzip it. You can unzip it in any unzip utility of your choice. I'm gonna just use jar command. Okay. So I'm gonna say jar xdf and name of the zip file. Then it will generate. It will create JPA Basics directory. And so if you go to JPA Basics directory, you're going to see index.html file and samples maven. So these are sample applications that we are going to work with, and this is a lab documentation. So using your browser, you are going to read that index.html file. So in my case, it's on the labs, and I'm going to go JPA Basics, and I have index HTML file. So this is the HTML documentation. So let me just increase the font size so that you guys can actually read it better. So the first thing we are going to do is we have to create database, and then we are going to import sample maven project. Okay. Now the database we are going to use is a Java DB. And later on you can use a MySQL, and you can actually, I'll let you know how you can actually use MySQL as well as part of this lab. Okay, but for now we are going to actually use Java DB database server. So there are two different ways that you can start Java DB database server. The easiest way to start Java DB database server is using NetBeans. NetBeans comes with GUI based Java DB manager. So if you have a NetBeans, you should be able to. I have studied NetBeans, and basically you select. So when you do open NetBeans, you're going to see projects, files, and services, and you select services, and one of the items you see is the databases. So you expand it, and then you're going to see Java DB. So you say Java DB and start server. So since it's already started, it's grayed out for me, but you should be able to start like this. Okay, and then if you do not want to use NetBeans, then you could actually start Java DB server from your JDK. JDK comes with the Java DB. So, basically you are going to specify your JDK DB directory as Derby home like this. Okay, so you might want to actually specify correct path and make sure you are actually setting the DB directory. And then you should be able to call set network server cpbat. So this is actually setting environment variable. And then you should be able to call start network server. So this is another way that you can start Java DB server. Okay, but I'm going to just use the NetBeans because starting and creating database in NetBeans is a lot more simpler than command line. The utility that are coming from JDK, but it's allowed. Okay, so once you have a Java DB database server up and running, we are going to create test DB database. Okay, so this is the database in Java DB server we are going to use for our lab. Okay, in order to create a database in again NetBeans, you basically say right click and then create database. Then you specify test DB. Yeah, in my case, it's already created, so that's the reason you say it already contains a file named testdb, and you say app, and app. So both username and password should be app, and the name of the database table is testdb. And if this is the first time, then you should have OK, and you can create it. Okay. If you want to create it at the command line, this is the command. So here. You go to your DB bin directory, and then you're going to use ij utility. Then you specify the driver like this, and then you're gonna connect and you provide name of your database, username and password, and you also set create equal true, and then it will create testDB database for you. Okay, so you can just copy this commands and then execute under your JDK DB bin directory. Okay, so once you have created, once you started the Java DB database server and you created testDB database, again in my case I have already created, so I have created Java testDB database right here. Okay, then you are going to import sample Maven project. So I'm going to actually use Eclipse to import sample Maven project. So basically you click file, and you can use any IDE of your choice. If you're using NetBeans or IntelliJ IDEA, it doesn't matter. So in Eclipse you use import, and then you are going to select Maven. So all sample projects are in the form of Maven project. So you have to make sure you are expanding Maven, and then select existing Maven projects and click next. And then you are going to go to the samples Maven directory of that lab. So in my case, again, it's a labs directory. And here, and I have a JPA Mavens, and I'm going to select samples Maven, and you select. Okay, and in fact, we have a bunch of sample projects, so we might as well just import all these sample project and finish. Okay, so we have these sample projects that are imported. Okay, if you're using NetBeans, you can just use open, and then again you go to the samples Maven directory and open those projects, and you should be able to see that. Okay, now we're going to actually do exercise 1. So exercise 1, we are going to try default data types, and exercise 2, we are going to use table and column annotation. Exercise 3 is ID, and exercise 4 and 5 are base 5 and 6 and 7. 4 and 5 and 6 are just using different the strategy for generating ID value. Okay, so we're going to actually build JPA Basics default database project first. So basically all you have to do is JPA default database, and you say right click and you say run as, and you are going to run as Java application. All these projects are in the form of Java application. So you run that project as a Java application, and you select your main method. So typically you're going to say just main, and you're going to see main class is under my package directory. So you choose that and you select OK. Then you can see it's actually running, and it actually shows you a table that contains ID, salary, bonus, and name, and some kind of boolean. And you have ID 2311, salary, and Bill Clinton, Angela Castillo, and Sang Shin. So this is what you are going to see. Okay. All right. So let's take a look at the code. So this is basically what we did. So this is what you see, and we can take a look at the source code. Okay. So this is the structure of your source code. Typically, the structure of the source code is here. We have entities directory that contains entity class. In this case, is employee entity class. Okay, so you can see it has entity annotation, and it has the ID with ID annotation. Then we have four the fields: string type, long and double, and boolean. So in this example, we want to see how these types of string, long, double, and booleans are mapped into column type. Okay. All right, and okay, so that is employee class, and we have employee service class is a utility class in which you are basically creating and it has a set of methods that you can use to create and delete and things like that. Okay, so we can actually touch upon that later on. And my package is a main class. This is where we are going to create entity manager. Then we are going to use entity service object to create 3 entities. We created 3 employee entities, and then when it's committed, those entity persistence objects will be mapped into the tables. Okay. All right, so that is that. So this is the code that we have just seen. This is the main code. We basically start the transaction, we create 3 employees, and then we commit. So whenever you say commit, it will actually make a changes to the database table. Okay. All right, and later on we are just displaying the employee table order by ID. Okay, so we just perform select star from employee order by ID SQL statement. And this is a persistence XML file in which we specify entity class and then we specify the database configuration. So here you are using Java DB client driver. This is the database of testDB, and this is username and password. Again, don't worry about if you don't understand this persistent XML5. We're going to actually talk about these things in detail. In this case, basically the exercise, the goal of this particular exercise is to verify the data type. Okay? So if you happen to have NetBeans, then I should be able to actually go to NetBeans here, and here I could actually make a connection to testDB. So I'm going to say connect, and it's connected, and I should be able to see, in fact, the employee table here, and I should be able to see the data. So I'm going to see the actual data that I just created. There should be 3 cases: Sang Shin, Bill Clinton, Angela Casedo, and you can see, you know, the type of salary is big int. You see here, bonus is a double, name is varchar to 55. Okay, so basically this is, you know, and this is boolean, and this is the small int. So this exercise is basically verifying the default mapping that we learned. Okay, so that this is basically to verify, you know, the default type mapping. If you want to use a command line, you can actually use a select star from it actually give you data like this. But if you want to actually see the type of it, then you have to actually, you know, you get the meta information of the table and things like that. Okay. All right. 1.2 is we want to use different custom table name and column name. Okay. All right. So here, let's actually run. Not NetBeans. I want to actually run it from Eclipse here. So here we are going to use table and column. So we are going to run it. Java application. And again, choose your main method and here. And you can see now the name of the table is changed to my own employee table. And the name of the column in this case is changed my bonus and my name. Okay. So if you take a look at the code, we actually use table annotation to use our own table name and our own column name and our own column name as well. One advantage of using this annotation is you can specify other attributes like nullable and updatable and things like that. Okay? So even if you don't want to change your, let's say, a column name, you might still want to use a column annotation to specify other attributes. Okay. By the way, these things are all, it all has some default values. So you want to specify these things only when you want to deviate from the default. Okay. So that's table and column. ID is, so this is a case that we are using, this is a case that we are not using generated value. Next case is we are using the auto, it's basically, if you don't specify anything, it's using auto. And the next case is you're using identity annotation. So here I'm using identity, the generation type. The last one is using, I think is a sequence. So it's just, just run it and see how things work out. And, just want to let you know that there are some strategies you can specify in terms of ID generation. Okay, so I am going to give you maybe about 10 minutes to do exercise 1. And if you want to actually play around it, for example, if you want to choose a different custom column name and different table name, feel free to do so. Okay, so I'll give you 10 minutes and